Hi, welcome back to Mrs. Ogram's Maths. This is the worked solutions for the Level 3 Calculus paper from 2023. So that's standard number 91579, and this is the integration paper. And one thing to note is that this video was made before the mark scheme was available. I'm making this soon after the paper has actually been sat, so I don't have the answers available. I've done as much checking as I possibly can, but if I do make mistakes, I will put them in as corrections under the video description, so you can look up to see if anybody has highlighted a correction that's needed, and I might have an amendment within the video description. And if you're watching this and you find something that you think is an error, please leave a comment with the timestamp and some details, and I will look into it. Thank you. Okay, so let's get stuck in with question 1. We're integrating each of these terms, so 3x becomes 3x squared over 2, 2 becomes 2x, and the 1 over integrates to be log of the thing that was inside of it, but it's also reverse chain rule, so we need to divide by that 3, so it's a third log 3x plus 2 plus c. We've got kinematics for part B, so we're looking at velocity, where we've got the equation for that velocity here as sec squared t. We want to find the distance of the object after a certain time. So to get to distance from velocity, we are going to integrate the sec squared t. Look on your formula sheet, you'll see that sec squared integrates to tan x plus c. Now we can use the information in the question to work out the c, which is that initially the object was 3k away from p. So s of 0 will be tan of 0 plus c, and that's equal to 3. Well, tan of 0 is 0, so therefore c equals 3. So now we want to find the distance of the object from P after pi by 4 hours. So the distance when we have pi by 4 put in is to do tan of pi by 4 plus 3. So tan pi divided by 4 plus 3 equals 4 kilometers. For part C, we're finding this shaded area in here. For that, we need to know the intersection points here and here. So if we set the square root of x to be equal to x squared over 8, so we're setting y equal to y in the equations, then we will have that 8 is equal to x squared over x to the half. Well, x squared over x to the half means we subtract the powers, so that's x to the 3 over 2. So if x to the 3 over 2 equals 8, then x is equal to 8 to the power of 2 over 3 to undo that, and that is a 4. So right here we have a 4, and this intersection is 0. You can also check this using the graphing function on here, so we can put y equals x to the power of 0.5 and y equals x squared divided by 8. We draw those, and then we do g-solve to find the intersection points. So we have x equals 0, and then move along to the next one, x equals 4. So now we are integrating between these two from 0 to 4. Now the top one is the square root. This line here is the square root graph. So we need to do x to the half for the square root minus x squared over 8, because our bottom line is this one here with respect to x. Okay, so this integrates to 2x to the 3 over 2 over 3. Or rather, I'll slow that down, sorry. Increase the power by 1, we have 3 over 2. Divide by the new power is to multiply by 2 over 3. Next one, increase the power by 1, we've got x cubed. Divide by the new power, well, we already had an 8 on the bottom, so now if we're dividing by 3, 3 times 8 is 24, between 0 and 4. So subbing in the values, 4 to the power, let's go back to our run menu. So 4 to the power of 3 over 2 times by 2, divide by 3, is going to be 16 over 3. 4 to the power of 3 is 64, divided by 24 is 8 over 3. And then if we were to sub in the 0, that's just a 0. So this is now 16 over 3, 16 over 3 minus 8 over 3 is 8 over 3. Right, for part D, we have that y's and x's all mixed up on one side, so we need to separate those variables before we can do any integration. Bring the y over to the left and it becomes 1 over y. Take the dx up and to the right, we have 2x minus 3x squared dx, and we are integrating both of those. So 1 over y becomes log y. 2x is x squared, then we have the divided by 2, so that cancels out. Similarly with the 3x squared, if we put this to the power of 3 and then we divide it by the 3, those are going to cancel too. So we've just got an x cubed plus c. Now we're told that when y equals 1, x equals 2. So we then have log of y is equal to 2 squared minus 2 cubed plus c, subbing those in. Oh, I forgot to put a 1 there, log of 1. Log of 1 is 0, so 0 equals 4 minus 8 plus c, so therefore c is equal to 4. Now we want to work this out when x is 1. So when x is 1, log y equals 1 minus 1 plus 4, just by subbing into the equation here where we've worked out that c is 4. So log y equals, 1 minus 1 cancels, so that's just 4. Y equals e to the 4. And if we want that in decimals, that will be equal to 54.6. I imagine they'll give you the answer either way for 54.6 or e to the 4. Okay, now we've got quite a bit to do on part E. I'm going to start by splitting these shaded areas into different portions because we'll do different things for them. So first of all, this portion under the curve here, that's going to be area A. Then this triangle here, I'm going to make that area C. And then we'll have the rest of it, this bit here, which is all of this portion just here. Okay, so let's start with A. That's the area between, or under the curve, which is this curve here. That's the sine curve that's been put on there, between 0 and its intersection point here. Now, these two curves, this one to do with sine and the one to do with y squared, both intersect with the x-axis at this same point here. The easiest one to use to find that is this one. So when we're on the x-axis, then the y portion is equal to 0. So x must be 10. So for area A, we're going to integrate between 0 and 10 of the minus sine pi by x over 10 curve. If we integrate sine, we get negative cos. So if we integrate negative sine, we get positive cos pi x by 10. And we need to divide by the derivative of what's in there so that we are doing the reverse chain rule. So that will be to times that by 10 over pi, between 0 and 10. So this then equals 10 over pi times by, if we put 10 pi, oh, hang on, one moment, let's go back to there. So 10 in for x, actually, well, if we were to put 10 in for x here, we're just doing pi then, so cos of pi is equal to -1. Now if we put 0 in, cos of 0 is equal to 1, so we're going to minus 10 over pi times 1. So in this case we will have, so we've got minus 10 over pi minus 10 over pi, so we've got minus 20 over pi. Now it makes sense that it's a minus because it's sitting underneath the x-axis here. Okay, let's go to, I'm going to do area C next. That's one of the easier ones to do. So we're looking at C here of that triangle. Now we're going to need to know where those two lines intersect, so 3x and y squared equals 10 minus x. I'm going to use the graphics calculator here. We can pop these in here, or you can solve it by doing it algebraically, set the y's equal to each other. This will be 10 minus x to the power of a half to do the square root, so we've got just y, and then draw it. Now g-solve, find that intersection point just up there, and that happens when x equals 1. So the area for C is a triangle, so that's half times the base, which is 1, times the height. Well, on this line here, the y is 3x, so if x is 1, the height here is 3, so we just have an area of 1.5. For B, we are integrating between 1 and 10, and this time we're on this curve here, so 10 minus x to the half. Okay, so here we have 10 minus x. We raise the power by 1, we'll get 3 over 2. Divide by that new power means we'll times by 2 over 3. We also need to divide by the derivative of the inside for reverse chain rule, which is a -1. So this becomes a minus here. We're going between 0 and 10. Right, sorry, it's not 0, it's 1 and 10 that we're going between. Right, if we were to pop 10 into here, then that's going to be a 0. So we've got a 0 for the first term. If we put 9 in, if we put the 1 in, this becomes a 9. So 9 to the power of 3 over 2, and then times it by -2 over 3. We're going to be taking away -18. So our answer here is 18. Now we can do total area. So total area will be -20 over pi plus 1.5 plus 18. So, oh, no, wait, sorry. The area on the first one's not going to be a minus. Add it as an absolute term, so 20 over pi. So we have 20 over pi, oops, there we go, plus 1.5 plus 18. Right, question 2, we are integrating this e function. So the e part doesn't change when we integrate, but we do need to account for the derivative of the inside, so we need to divide by that 2. So 4 divided by 2 is 2, and then plus c. Solving this differential equation means we are going to integrate it. So y is equal to the integral of 4x plus 1 to the minus a half with respect to x. So reverse chain rule, we raise the power by 1, so this will be a half, and we divide by the new power, so dividing by a half gives us a 2 at the front. We also need to divide by the 4 that is inside. So that would actually be, instead of a 2 at the front, 2 divided by 4 is going to be a half. And we can work out the plus c by using these two values here. So if y is 7.5, that will be equal to a half of 4 times 6 plus 1 to the half plus c. Okay, so 4 times 6 plus 1, that's 25. We need to do the square root of that because that's what the power of a half means. Divide it by 2, and we will get that c must be 5. So y equals a half 4x plus 1 to the half plus 5. Or if you wanted to write that in square root form, we would have a half times the square root of 4x plus 1 plus 5. Either way is fine. See, the first thing I'm going to do before attempting to integrate is sort out this fraction that we have. I'm going to do, you could either do long division or other methods. I'm going to do a method that sometimes is referred to as algebraic juggling. So we're just fixing the top so that it's something to do with the bottom, and then we'll be able to simplify. So if I start by putting 2x minus 3 on the top, because that's our denominator, so match it to the denominator. To make the 6x from that, I would need a 3 at the front. Now, if I was to multiply that out, I would get 6x and I would get minus 9. I only wanted the 6x from that bit, so add the 9 back on to make it equivalent. Then pop the minus 3 back in. So this plus 9 take away 3 is going to end up being plus 6. Now that will be equal to, we can separate the pieces of that fraction into being 2x minus 3 over, 3 times 2x minus 3 over 2x minus 3 plus 6 over 2x minus 3. The 2x minus 3 cancels, so we just have a 3 plus 6 over 2x minus 3. Let's just bring that bit closer. Okay, so now those bits we can integrate. So that's 3x plus 6 times the natural log of 2x minus 3, and then divide by the 2 that was inside. So that will be plus 3 log 2x over 3. Now we're doing that between 2 and k, and we'll be told that we've been told it's equal to 3k. So substituting in k now, so we've got 3k plus 3 log of 2k minus 3. Take away, if we, I'm going to move that over a little bit, if we substitute in the 2, we'd have 6 plus 3 log of 2 times 2 is 4, take away 3 is 1. Now that happens to come to 0. So now we need to just rearrange this a little bit. And we're aiming to find the value of k, so we're wanting k equals. That's our aim. So the 3k on either side cancels. We have 3 natural log of 2k minus 3 minus 6 is equal to 0. So natural log of 2k minus 3 is equal to 6 over 3, or 2. So 2k minus 3 equals e to the 2, and k is e to the 2 plus 3 over 2. And if we want to do that on the calculator, I imagine they'll give that as a correct answer as it is, like so. But if we need the decimal, then that would be 5.19. Now, part D is actually quite tricky to spot what to do with this. And you might try a few different things of looking on the formula sheet for what trig things might help you out. But the key here was knowing that cos and sine differentiate to get each other. So the top thing that we have is something to do with the derivative of the bottom, which means we can use natural log. So if we try a value of y being the denominator, so cos of 2x minus sine of 2x, and then we were to differentiate that, we would get minus 2 sine 2x minus 2 cos 2x. Now you can see that this is similar to this, but not quite exactly that. Okay, so if I was to take this one and integrate it, then I would get the bottom. But we have a multiple of it happening here, rather than it being a direct derivative of it. And the multiple that we have in this is that minus 2. So we've got minus 2. If I rewrite this in the order that it is on that denominator, it might make it easier to see as well. So it's almost what we wanted it to be on the top, but not quite. Which means that I need to adjust what I'm using so that it does match. Now that adjustment would be to times this by a minus a half, because then if I times this by a minus a half, it will cancel out the negative 2 that we had at the front. So then our integral, so this integral of cos 2x plus sine 2x over cos 2x minus sine of 2x. When the top is a derivative of the bottom, then the answer to that integral is the natural log of the bottom, like this, but it wasn't directly exactly equal to. We have to use this minus half in there so that it does turn out to be equal to, that fixes it up. Now that was a really tricky one. It was difficult for me to spot that first time going through. So don't beat yourself up if you don't spot it so quickly. These ones come with a bit of practice. The other thing you can do in the exam is once we've got this, differentiate it and check that it comes back to that, and you'll find that it's equal. Okay, so this question is about proportional rates, but it's not your bulk standard type of question. It's actually quite a tricky one in my opinion, because they didn't give us the amount that was at the start, but they gave us the amount after an hour and then after a second hour. Makes it just a tiny bit harder. And the other thing is that the amount was given to us that it includes a p that's going to force you to do this all by hand with algebra, and no extra help really on the calculator. Okay, so let's start by picking out the pieces that we have, which is that the rate of change of the volume is proportional to the square of the volume. Let's start by writing that down. So the rate at which the volume changes, so dv by dt, is proportional to, means we do equals k times the thing it's proportional to, which is the volume squared. So now separating variables, bring the v over to the left, and we leave the k where it is, and we put the dt up there. We're going to integrate both sides. Now 1 over v squared is the same as v to the minus 2. So if we increase the power by 1, we get minus 1, and we're going to divide by the new power, so dividing by minus 1 makes that a negative. So that's equal to kt plus c by integrating that right-hand side. And I'll just rewrite this as 1 over v. It's probably going to help later on. Okay, now, information in the question. After 1 hour, the volume is p. So when t equals 1, we can put the volume in for v as being p. So minus 1 over p is equal to k times 1 plus c. Now the second bit of information, after another hour, the volume is equal to 4/5 of p. So when t is 2, we have minus 1 over 4/5 of p. I'm going to write it as 0.8p at this stage just to keep things... Actually, no, I won't. So we'll do 4/5 of p just here is equal to 2k plus c. So now if I take equation 1 and 2, and think about it sort of like we're solving simultaneous equations. If I do number 2 minus number 1, then on the left-hand side, I'm going to do 2k plus c minus k plus c. So 2k plus c take away k plus c is equal to minus 1 over 4/5 p take away minus 1 over p. So with that, if I take out that bracket, then that's going to be k minus c. So the c's cancel. I've got 2k minus k on the left, so k is equal to this thing on the right. If I do minus 1 divided by 4/5 of p, that's the same as if I was timesing by 5 over 4p plus 1 over p. Now that, the minus 1 times the 5, I'm going to write as minus 5 over 4p. If I want to put this together as a common denominator, that's minus 5 over 4p plus 4 over 4p. So minus 4 plus 4, that's going to be equal to minus 1 over 4p. Now for c, if I use equation 1, I can work out what c is. So this bit just here, if I rearrange that, c is going to be minus 1 over p minus k, but k we just worked out to be minus 1 over 4p. So that's equal to, let's put it all over a common denominator of 4p. We'll have minus 4 over 4p plus 1 over 4p. So that's minus 4 plus 1 is going to be minus 3 over 4p. Okay, so we've got k, we've got c. The last bit of the question is, let me just get the highlighter, calculate how much liquid chocolate was in the container at the start. So we want to work out when t is 0. So when t is 0, we've got our equation for v was up just here. So I'm using that equation now. Minus 1 over v is equal to k times t. Well, t is 0, so we can ignore that bit. It's just equal to the c value, minus 3 over 4p. So the minuses cancel, and if we reverse or flip over both of those fractions, we get v is equal to 4p over 3. That, I think, was a particularly hard excellence, and a little bit meaner than usual. Now, question 3, we have a Simpson's rule question to find this area. What we need to be able to do is interpret from the diagram the pieces of the Simpson's rule. So the h is the 3 meters that runs that width there. So for the Simpson's rule, we're going to have a third times by h, so that's times by 3. Then we take the first and the last values, pop them in. Then we're going to do 4 times the odd position. So this is position number 1. Remember that this one here counts as position 0. So this is, sorry, not x, it's the y value 0. This is y1 and this is y3. So our 4 gets times by 13 plus 15. And then y2 is this one here. So that's going to be 2 times by 16. And let's pop that in the calculator. So we have 13 plus 15, times it by 4, then add 2 times 16, which is 32. Add on the 10, add the 14, and then if we times by 3 and then times by a third, that's going to cancel out. So our final answer here is that is equal to 168 meters squared. So with this fraction, we will first separate it out into two pieces, which we can do if we've just got a single thing on the denominator, but 2 bits on the numerator. We can do it like this. So root x over root x cancels, that's just 1. And root 3 over, oh wait, sorry, it's not root 3, it's just 3. So 3 over root x can be expressed as minus 3x to the minus a half, to make it a bit easier to deal with. So 1, if we integrate that, we get x. If we raise the x from minus a half, raising that power by 1 gives us a 1 over 2. We divide by the new power, so we're doing minus 3 divided by a half. So negative 3 divided by a half is just going to be a 6, and then plus c. Okay, part C, we have this curve. We're finding the area underneath it, so we need to integrate between 0 and pi by 3 for the function 5 sine 3x sine x. Now this function that we've got here, you need to recognize that as being one of the trig things that's on the formula sheet, and we can use the one that goes sine sine to separate it into two different pieces. So the rule on the formula sheet says 2 sine A sine B equals cos of A minus B minus, let's just move it over just a smidgen. Here we go. Minus cos of A plus B. So putting that into what we have here, first I need to divide the 5 by 2, because this will be a 2 times thing. So this is equal to 2.5 times 2 sine 3x sine x. If we're going between 0 and pi by 3. Okay, so that we can take the 2.5 out of that integral. We can change the 2 sine 3x sine x into something in this form. So this will be this will be cos of A minus B, so 3x minus x is 2x, minus cos of A plus B, 3x plus x is 4x. Okay, now to integrate that, we are going to do 2.5, and the integral will be, if we integrate cos x, we get sine x, so this will be sine 2x, and then divide by the half to counteract the 2 that we had there, and then minus, again cos goes to sine, so this will be sine 4x, and we need to divide by the 4 because of the 4 that's inside of 4x. Then we'll sub in the values for pi by 3 and 0. Okay, so if I put pi by 3 in as our answer, first of all I'm doing 0.5 sine of 2 times that. Let me just pop some brackets around there just in case. And then we're going to minus a quarter sine of 4 times pi by 3. Then, okay, so we've got 2.5, 0.6495 minus, if I put 0 in for sine, then that I get 0. So each of those would be a 0 when we sub in the value of 0. So now I can just do 0.6495 times by 2.5, and we get our area is 1.62. Okay, so we want velocity for this question. To get velocity from acceleration, we are going to integrate. So we are integrating e to the 2t over 4e to the 2t minus 3. Okay, now the top is something to do with the derivative of the bottom. If we differentiate the bottom, we get 8e to the 2t, which is almost what we want, but is 8 times too big because we don't have an 8 in the front just there. So we'll do 1/8 of log of the bottom, 4e to the 2t minus 3, and then plus c. Now we know that when t is equal to 0, we have a velocity of 5. So we can sub that in to give us 1/8 log of 4e to the 0 minus 3 plus c equals 5. Okay, so e to the 0 is 1. So this bit becomes just 4. 4 minus 3 is 1, and log of 1 is 0, just like this. So we end up with c being 5. So then we want to find out the velocity when t is 4. So v of 4 will be 1/8 natural log 4e to the 2 times 4 minus 3 plus 5. So 1/8 times by the natural log of 4e to the 8, take away 3, and then plus 5. 6.17, and we're measuring in meters per second. All right, let's finish off the last excellence of this paper. We have x's and y's all jumbled together, so we need to separate the variables. And we'll start by getting dy by dx on its own. So this would, if we take this portion over to the right, we'll have minus 1 over x, 1 minus y squared. And then we take this portion over and divide it, then we will have 1 minus x squared, 1 plus y. Now, taking the y's all over to the left-hand side and the x's to the right means that we're going to take this over and divide. So we will have on the bottom of our fraction 1 minus y squared. We're going to take this over and times it. So on the top we have 1 plus y. For the x's, oh, sorry, that should have been a dy. For the x's, we leave them where they are. So minus 1 minus x over 1 minus x squared dx. And we're trying to integrate these two things. Now, this is the tricky part on this one, is being able to simplify this into something we can integrate. At the moment, we can't integrate this. But what you needed to recognize is that on the bottom of each of these, we have a difference of 2 squares. And that means that we can do some clever algebra with it to do some simplifying. So this will be 1 minus y, 1 plus y. And this is 1 minus x, 1 plus x. So now you can see we can cancel through those brackets there and this one here. And we're left with this being the integral of 1 over 1 minus y and the integral of minus 1 over 1 plus x. Okay, so then the next stage of integrating that, we have the natural log of 1 minus y on the left, and we need to divide by the minus 1 that's the derivative of the inside. So this ends up being a minus log 1 minus y. On the right, we have the natural log of 1 plus x. We have the minus that came from being up here. We need to divide by the 1 that's in here, but that doesn't change anything. And then plus c. So log of 1 minus y is equal to log of 1 plus x plus c. Okay, now back to the question for some information to help us work out the c. When y is 0, x is 2. So log of 1 minus 0 is equal to log of 1 plus 2 plus c. Well, log of 1 minus 0, log of 1 is 0. log 3 plus c. So c equals minus log 3. Okay, now what are we trying to work out? We want the value of y when x equals 6. Okay, so when x equals 6, log of 1 minus y is equal to log of 1 plus 6 minus log of 3. So 1 minus y equals, actually I won't skip this step, so log of 7 minus log of 3, that's equal to log of 7 over 3. So 1 minus y equals 7 over 3. If we times it through by 3, we get 3 minus 3y equals 7. So 3y equals minus 4, and y is minus 4 over 3.